Hello friends! Welcome to learning about base 10s with Miss Woodward. Before we get started, make sure you have a sheet of paper and a pencil for you to practice some examples later on in the lesson. Let's get started! Does anyone know what base 10 means? We are going to be using tens to determine when we regroup. With our base 10 blocks, we will be using 1, 10, and 100 to do this. Let's look at some base 10 blocks to learn how we can do this. We use base 10 blocks to show how to regroup digits into different place values. Does anyone know what regrouping is? Pause the video so you can think about it and push play when you have an idea. Regrouping is when you reorganize your numbers or items into new categories because you have a new amount to fit that category. In this case, we are regrouping blocks when we have enough blocks to create the next highest category. As you can see above, one yellow box is called a unit, 10 yellow blocks are called a long, and 100 yellow blocks are called a flat. Let's look at this again. If we have 10 units, that is 10 single blocks, we can regroup it into one long. So we are trading it in for one long by putting them together. This is the same idea when we have 10 longs. That's 10 groups of 10 each. We regroup that into one flat, which is now one big block of 10 columns of 10 blocks, which means 100 blocks total are there all put together. What do these blocks have to do with place values? Let's just start by asking the question, what are place values? Place values tell you what type of block to use. We have 3 blocks that we are going to be looking at today. The unit, which we learned was 1, the long, which we learned is 10, and the flat, which we learned is made of 100 blocks. Now let's see how these blocks look on paper. So place values using base 10 blocks tell you what type of box to use. This is our place value diagram that we will be using throughout the lesson, so it's important for us to understand how it works. If you have a digit in this spot, that is how many units you have. If you have a digit in that spot of the number, that is how many longs you have. And if you have a digit at this part of the number, this is how many flats you have. Let's practice this idea of using base 10 blocks with our place values. If I have 15 pieces of candy, how many boxes would I need, and what kind of boxes? Let's start by counting out our 15 candies. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So how many single pieces of candy do we have in a box right now? Yep, 15. So how many candies can we fit in a long box? 10. Nice job. Do we have 10 pieces of candy that we could put in a long box right now? You betcha. Let's put that into a long. Okay, so we have a long representing the 10 unit candies circled right now. Do we have enough candies left over to fill another long? Nope. What kind of boxes will we use instead? That's right, 5 unit boxes. So how many boxes did we use to fit our 15 pieces of candy? 1 long box and 5 unit boxes. Let's put these boxes on our place value diagram. We need to place our 15 pieces of candy onto this diagram. Where would we put the 5? That's right, in the unit spot. Now, what about the 1 long? Where would that go? You got it, in the long place value. When we place those numbers on their place value spots, what number do we make? That's right, 15. Pause this video to read the question. When you're finished reading it, hit play, and we will go to the next slide where we will learn how to solve this problem. The number 328 is too big to make individual unit boxes for each one, So let's try another way. This time, we're going to start with our place value diagram and end with our base 10 blocks. Let's use our place value diagram from earlier. Let's place the number 328 into the diagram. Pause the video and try to place this number in the diagram by yourself. Does your diagram look like this? Good job! What does this mean? Pause the video and use base 10 blocks to show how many boxes we need for all this candy. Then, hit play when you're ready to move on to the next slide, and we will do this all together. We need to place boxes for each of these numbers. How many unit boxes do we make? 8. And how many long boxes do we make next? 2. And how many flat boxes would we use? 3. How did you come up with this? Notice, the number on top matches the number of boxes made on the bottom. We have 328 candies packaged into 3 flats, 2 longs, and 8 units. Let's review how many candies are in each of our box types. How many candies are in our unit boxes if we have 8 unit boxes, and there is 1 candy in each? Pause this video to solve this. How did you solve this? I solved it by adding 1 plus 1 8 times. Did we get the same answer? 8! Way to go! How many candies are in our long boxes if there are 10 candies in each long and we have 2? Pause the video to solve the problem 10 plus 10. Did you get the same answer? 20 candies! Nice job! Now, how many candies are in our flat boxes if there are 100 candies in each flat and we need to add 100 plus 100 3 times? Pause the video to solve this problem. Did you get 302? Nice! You're really getting this! Our last step is to add all the candies from our unit, long, and flat boxes. Let's do this together. Let's begin by putting the number of candies in each of our box types into an addition number sentence. Pause the video to try this on your own. Does your number sentence look like this? Great job! Now we need to add up all of these candies. What is 8 plus 20 plus 300? That's right, 328. Does your answer match the number of candies we started with? You betcha! Now, let's move on to the base 10 place values that we use in our number systems. Does this place value diagram look familiar? This is the same diagram we used with our unit, long, and flat boxes. The only difference is I switched out our box labels for the labels used in the number system. Let's use our 328 candies to fill in this chart. How many units do we have? 8. Those are now in the ones place, so we have 8 ones. How many longs do we have? 2. Those are now in the tens place, so we have 2 tens. And how many flats did we have? 3. We now have 3 hundreds instead of 3 flats. We can still use our base 10 blocks to help us understand this new place value system. We just trade out the term units, longs, and flats for tens, ones, and hundreds. Let's practice. I want you to place these numbers on our new place value diagram and then tell me how many ones, tens, and hundreds there are in each number. Let's start with 52. First, we draw in our place value diagram. Then we're going to place 52 into it. Where should you put the 5? That's right, in the tens column. What about the 2? Yep, in the ones. How many tens and ones do we have? That's right. There are 2 ones and 5 tens. I want you to try 735 on your own. Pause the video and push play when you're ready to check your answer. Let's put in our place value diagram again. How many hundreds do we have? 7. And how many tens do we have? 3. Now where does the 5 go? Yep, in the ones column. So, how many hundreds, tens, and ones did we end up with? That's right, 5 ones, 3 tens, and 7 hundreds. You got this. I hope you all learned something new about base 10 place values. If you're confused by any part of the video, please go back and rewatch it or ask me in class. Thanks for watching!